Long Shot by Vernor Vinge. Originally published in the August 1972 issue of Analog magazine. The very next year it appeared in two best of anthologies, these being the 1973 annual World's Best SF, which had a German translation in 1975, and Best Science Fiction Stories of the Year, second annual collection. Further anthology inclusions came in Countdown, a German publication from 1980, Machines That Think, the best science fiction stories about robots and computers in 1984, and perhaps the highest honor any story could receive insofar as anthology inclusions can go. In 1985, it appeared in Great Science Fiction, Stories by the World's Great Scientists. It appeared in a collection of the author's stories in 1987 entitled True Names and Other Dangers, and another in 2001 called The Collected Stories of Vernor Vinge. Read by Darrell T. Smith II for my channel, Quasar Spectra. Editor Donald A. Wollheim says about this story, "We've had a lot of automated spaceship stories, but this one is different. On the surface, it could be said that there isn't a human character in it, but to insist on that would be sheer folly." Long Shot. They named her Ilsa, and of all Earth's creatures, she was to be the longest lived, and perhaps the last. A prudent tortoise might survive 300 years, and a bristlecone pine 6,000, but Ilsa's designed span exceeded 100 centuries. And though her brain was iron and germanium doped with arsenic, and her heart was a tiny cloud of hydrogen plasma, Ilsa was, in the beginning, one of Earth's creatures. She could feel, she could question, and, as she discovered during the dark centuries before her fiery end, she could also forget. Ilsa's earliest memory was a fragment, amounting to less than 15 seconds. Someone, perhaps inadvertently, brought her to consciousness as she sat atop her S5N booster. It was night, but their launch was imminent, and the booster stood white and silver in the light of a dozen spotlights. Ilsa's sharp eye scanned rapidly around the horizon, untroubled by the glare from below. Stretching away from her to the north was a line of 30 launch pads. Several had their own boosters, though none were lit up as Ilsa's was. 3,000 meters to the west were more lights, and the occasional sparkle of an automatic rifle. To the east, surf marched in phosphorescent ranks against the Merritt Island shore. There, the fragment ended. She was not conscious during the launch, but that scene remained forever her most vivid and incomprehensible memory. When next she woke, Ilsa was in low Earth orbit. Her single eye had been fitted to a 150-centimeter reflecting telescope, so that now she could distinguish stars set less than a tenth of a second apart, or, if she looked straight down, count the birds in a flock of geese 200 kilometers below. For more than a year, Ilsa remained in this same orbit. She was not idle. Her makers had allotted this period for testing. A small manned station orbited with her, and from it came an endless sequence of radioed instructions and exercises. Most of the problems were ballistic, hyperbolic encounters, transfer ellipses, and the like, but it was often required that Ilsa use her own telescope and spectrometer to discover the parameters of the problems. A typical exercise: determine the orbits of Venus and Mercury. Compute a minimum energy flyby of both planets. Another: determine the orbit of Mars. Analyze its atmosphere. Plan a hyperbolic entry subject to constraints. Many observational problems dealt with Earth. Determine atmospheric pressure and composition. perform multispectrum analysis of vegetation. Usually she was required to solve organic analysis problems in less than 30 seconds, and in these last problems the rules were often changed even while the game was played. Her orientation jets would be caused to malfunction. Critical portions of her mind and senses would be degraded. One of the first things Ilsa learned was that in addition to her private memories, she had a programmed memory, a library of procedures and facts. As with most libraries, the programmed memory was not as accessible as Ilsa's own recollections, but the information contained there was much more complete and precise. The solution program for almost any ballistic or chemical problem could be lifted from this library, used for seconds or hours as an integral part of Ilsa's mind, and then returned to the library. The real trick was to select the proper program on the basis of incomplete information, and then to modify that program to meet various combinations of power and equipment failure. Though she did poorly at first, Ilsa eventually surpassed her design specifications. At this point, her training stopped, and for the first, but not the last, time, Ilsa was left to her own devices. Though she had yet to wonder on her ultimate purpose, still she wanted to see as much of her world as possible. She spent most of each daylight pass looking straight down, trying to see some order in the jumble of blue and green and white. She could easily follow the supply rockets as they climbed up from Merritt Island and Baikonur to rendezvous with her. In the end, more than 100 of the rockets were floating about her. As the weeks passed, the squat white cylinders were fitted together on a spidery frame. Now her 10-meter-long body was lost in the webwork of cylinders and girders that stretched out 200 meters behind her. Her programmed memory told her that the entire assembly massed 22,563,901 tons, more than most ocean-going ships, and a little experimenting with her attitude control jets convinced her that this figure was correct. Soon her makers connected Ilsa's senses to the mammoth's control mechanisms. It was as if she had been given a new body, for she could feel and see and use each of the 100 propellant tanks and each of the 15 fusion reactors that made up the assembly. She realized that now she had the power to perform some of the maneuvers she had planned during her training. Finally, the great moment arrived. Course directions came over the maser link with the manned satellite. Ilsa quickly computed the trajectory that would result from these directions. The answer she obtained was correct, but it revealed only the smallest part of what was in store for her. In her orbit 200 kilometers up, Ilsa coasted smoothly toward high noon over the Pacific. Her eye was pointed forward so that on the fuzzy blue horizon she could see the edge of the North American continent. Nearer, the granulated cloud cover obscured the ocean itself. The command to begin the burn came from the manned satellite, but Ilsa was following the clock herself, and she had determined to take over the launch if any mistakes were made. 200 meters behind her, deep in the maze of tanks and beryllium girders, Ilsa felt magnetic fields establish themselves, felt hydrogen plasma form, felt fusion commence. Another signal from the station, and propellant flowed around each of 10 reactors. Ilsa and her 20,000-ton booster were on their way. Acceleration rose smoothly to 1 gravity. Behind her, vidicons on the booster's superstructure showed the Earth shrinking. For half an hour, the burn continued, monitored by Ilsa and the manned station now fallen far behind. Then Ilsa was alone with her booster, coasting away from Earth and her creators at better than 20 kilometers a second. So Ilsa began her fall toward the sun. For 11 weeks she fell. During this time there was little to do. Monitor the propellants, keep the booster's sunshade properly oriented, relay data to Earth. Compared to much of her later life, however, it was a time of hectic activity. A fall of 11 weeks toward a body as massive as the sun can result in only one thing: speed. In those last hours, Ilsa hurtled downward at better than 250 kilometers per second, an Earth-to-Moon distance every half hour. 45 minutes before her closest approach to the sun, perihelion, Ilsa jettisoned the empty first stage and its sunshade. Now she was left with the 2,000-ton second stage, whose insulation consisted of a bright coat of white paint. She felt the pressure in the propellant tanks begin to rise. Though her telescope was pointed directly away from the sun, the vidicons on the second stage gave her an awesome view of the solar fireball. She was moving so fast now that the sun's incandescent prominences changed perspective even as she watched. 17 minutes to perihelion. From somewhere beyond the flames, Ilsa got the expected maser communication. She pitched herself and her booster over so that she looked along the line of her trajectory. Now her own body was exposed to the direct glare of the sun. Through her telescope, she could see luminous tracery within the solar corona. The booster's fuel tanks were perilously close to bursting, and Ilsa was having trouble keeping her own body at its proper temperature. 15 minutes to perihelion. The command came from Earth to begin the burn. Ilsa considered her own trajectory data and concluded that the command was 13 seconds premature. Consultation with Earth would cost at least 16 minutes, and her decision must be made in the next 4 seconds. Any of man's earlier, less sophisticated creations would have accepted the error and taken the mission on to catastrophe. But independence was the essence of Ilsa's nature. She overrode the master command and delayed ignition till the instant she thought correct. The sun's northern hemisphere passed below her, less than 3 solar diameters away. Ignition, and Ilsa was accelerated at nearly 2 gravities. As she swung toward what was to have been perihelion, her booster lifted her out of elliptic orbit and into a hyperbolic one. Half an hour later, she shot out from the sun into the spaces south of the ecliptic at 320 kilometers per second, about 1 solar diameter every hour. The booster's now empty propellant tanks were between her and the sun, and her body slowly cooled. Shortly after burnout, Earth offhandedly acknowledged the navigation error. That is not to say that Ilsa's makers were without contrition for their mistake, or without praise for Ilsa. In fact, several men lost what little there remained to confiscate for jeopardizing this mission and man's last hope. It was simply that Ilsa's makers did not believe that she could appreciate apologies or praise. Now, Ilsa fled up out of the solar gravity well. It had taken her 11 weeks to fall from Earth to Sol, but in less than 2 weeks she had regained this altitude, and still she plunged outward at more than 100 kilometers per second. That velocity remained her inheritance from the sun. Without the gravity well maneuver, her booster would have had to be 500 times as large, or her voyage 3 times as long. It had been the very best that men could do for her, considering the time remaining to them. So began the voyage of 100 centuries. Ilsa parted with the empty booster and floated on alone. A squat cylinder, 12 meters wide, 5 meters long, with a large telescope sticking from one end. 4 light-years below her in the well of the night, she saw Alpha Centauri, her destination. To the naked human eye, it appears a single bright star, but with her telescope, Ilsa could clearly see 2 stars, one slightly fainter and redder than the other. She carefully measured their position and her own, and concluded that her aim had been so perfect that a mid-course correction would not be necessary for 1,000 years. For many months, Earth maintained maser contact to pose problems and ask after her health. It was almost pathetic, for if anything went wrong now or in the centuries to follow, there was very little Earth could do to help. The problems were interesting, though. Ilsa was asked to chart the non-luminous bodies in the solar system. She became quite skilled at this and eventually discovered all 9 planets, most of their moons, and several asteroids and comets. In less than 2 years, Ilsa was farther from the Sun than any known planet, than any previous terrestrial probe. The Sun itself was no more than a very bright star behind her, and Ilsa had no trouble keeping her frigid innards at their proper temperature. But now it took 16 hours to ask a question of Earth and obtain an answer. A strange thing happened. Over a period of 3 weeks, the sun became steadily brighter until it gleamed 10 times as luminously as before. The change was not really a great one. It was far short of what Earth's astronomers would have called a nova. Nevertheless, Ilsa puzzled over the event in her own way for many months, since it was at this time that she lost maser contact with Earth. That contact was never regained. Now Ilsa changed herself to meet the empty centuries. As her designers had planned, she split her mind into 3 co-equal entities. Theoretically, each of these minds could handle the entire mission alone, but for any important decision, Ilsa required the agreement of at least 2 of the minds. In this fractionated state, Ilsa was neither as bright nor as quick-thinking as she had been at launch. But scarcely anything happened in interstellar space, the chief danger being senile decay. Her 3 minds spent as much time checking each other as they did overseeing the various subsystems. The one thing they did not regularly check was the programmed memory, since Ilsa's designers had, mistakenly, judged that such checks were a greater danger to the memories than the passage of time. Even with her mentality diminished, and in spite of the caretaker tasks assigned her, Ilsa spent much of her time contemplating the universe that spread out forever around her. She discovered binary star systems, then watched the tiny lights swing back and forth around each other as the decades and centuries passed. To her, the universe became a moving, almost a living thing. Several of the nearer stars drifted almost a degree every century, while the great galaxy in Andromeda shifted less than a second of arc in 1,000 years. Occasionally, she turned about to look at Sol. Even 10 centuries out, she could still distinguish Jupiter and Saturn. These were auspicious observations. Finally, it was time for the mid-course correction. She had spent the preceding century refining her alignment and her navigational observations. The burn was to be only 100 meters per second. So accurate had been her perihelion impulse. Nevertheless, without that correction, she would miss the Centaurian system entirely. When the second arrived and her alignment was perfect, Ilsa lit her tiny rocket and discovered that she could obtain, at most, only 3/4 of the rated thrust. She had to make 2 burns before she was satisfied with the new course. For the next 50 years, Ilsa studied the problem. She tested the rocket's electrical system hundreds of times and even fired the rocket in microsecond bursts. She never discovered how the centuries had robbed her, but extrapolating from her observations, Ilsa realized that by the time she entered the Centaurian system, she would have only 1,000 meters per second left in her rocket, less than half its designed capability. Even so, it was possible that, without further complications, she would be able to survey the planets of both stars in the system. But before she finished her study of the propulsion problem, Ilsa discovered another breakdown. the most serious she was to face. She had forgotten her mission. Over the centuries, the pattern of magnetic fields on her programmed memory had slowly disappeared, the least used programs going first. When Ilsa recalled those programs to discover how her reduced maneuverability affected the mission, she discovered that she no longer had any record of her ultimate purpose. The memories ended with badly fated programs for biochemical reconnaissance and planetary entry, and Ilsa guessed that there was something crucial left to do after a successful landing on a suitable planet. Ilsa was a patient sort, especially in her crew's configuration, and she didn't worry about her ultimate purpose, so far away in the future. But she did do her best to preserve what programs were left. She played each program into her memory and then back to the programmed memory. If the process were repeated every 70 years, she found that she could keep the programmed memories from fading. On the other hand, she had no way of knowing how many errors this endless repetition was introducing. For this reason, she had each of her subminds perform the process separately, and she frequently checked the ballistic and astronomical programs by doing problems with them. Ilsa went further. She studied her own body for clues as to its purpose. Much of her body was filled with a substance she must keep within a few degrees of absolute zero. Several leads disappeared into this mass. Except for her thermometers, however, she had no feeling in this part of her body. Now she raised the temperature in this section a few thousandths of a degree, a change well within design specifications, but large enough for her to sense. Comparing her observations and the section's mass with her chemical analysis programs, Ilsa concluded that the mysterious area was a relatively homogeneous body of frozen water, doped with various impurities. It was interesting information, but no matter how she compared it with her memories, she could not see any significance to it. Ilsa floated on and on. The period of time between the mid-course maneuver and the next important event on her schedule was longer than man's experience with agriculture had been on Earth. As the centuries passed, the two closely set stars that were her destination became brighter until, 1,000 years from Alpha Centauri, she decided to begin her search for planets in the system. Ilsa turned her telescope on the brighter of the two stars. Call it Abel. She was still 35,000 times as far from Abel and the smaller star. Call it Baker, as Earth is from Sol. Even to her sharp eye, Abel didn't show as a disk, but rather as a diffraction pattern, a round blob of light, many times larger than the star's true disk, surrounded by a ring of light. The faint gleam of any planets would be lost in the diffraction pattern. For 5 years, Ilsa watched the pattern, analyzed it with one of her most subtle programs. Occasionally, she slid occulting plates into the telescope and studied the resulting distorted pattern. After 5 years, she had found suggestive anomalies in the diffraction pattern, but no definite signs of planets. No matter. Patient Ilsa turned her telescope a tiny fraction of a degree, and during the next 5 years she watched Baker. Then she switched back to Abel. 15 times Ilsa repeated this cycle. While she watched, Baker completed 2 revolutions about Abel, and the star's maximum mutual separation increased to nearly 1/10 of a degree. Finally, Ilsa was certain. She had discovered a planet orbiting Baker and perhaps another orbiting Abel. Most likely they were both gas giants. No matter, she knew that any small inner planets would still be lost in the glare of Abel and Baker. There remained less than 900 years before she coasted through the Centauran system. Ilsa persisted in her observations. Eventually, she could see the gas giants as tiny spots of light, correlations in her carefully collected diffraction data. 400 years out, she decided that the remaining anomalies in Abel's diffraction pattern must be another planet, this one at about the same distance from Abel as Earth is from Sol. 15 years later, she made a similar discovery for Baker. If she were to investigate both of these planets, she would have to plan very carefully. According to her design specifications, she had scarcely the maneuvering capability left to investigate one system. But Ilsa's navigation system had survived the centuries better than expected, and she estimated that a survey of both planets might still be possible. 350 years out, Ilsa made a relatively large course correction, better than 200 meters per second. This change was essentially a matter of pacing. It would delay her arrival by 4 months. Thus she would pass near the planet she wished to investigate, and if no landing were attempted, her path would be precisely bent by Abel's gravitational field, and she would be cast into Baker's planetary system. Now Ilsa had less than 800 meters per second left in her rocket, less than 1% of her velocity relative to Abel and Baker. If she could be at the right place at the right time, that would be enough, but otherwise... Ilsa plotted the orbits of the bodies she had detected more and more accurately. Eventually, she discovered several more planets, a total of 3 for Abel and 4 for Baker, but only her 2 prime candidates, call them Abel 2 and Baker 2, were at the proper distance from their suns. 18 months out, Ilsa sighted moons around Abel 2. This was good news. Now she could accurately determine the planet's mass, and so refine her course even more. Ilsa was now less than 50 astronomical units from Abel and 80 from Baker. She had no trouble making spectroscopic observations of the planets. Her prime candidates had plenty of oxygen in their atmospheres, though the farther one, Baker 2, seemed deficient in water vapor. On the other hand, Abel 2 had complex carbon compounds in its atmosphere, and its net color was blue-green. According to Ilsa's damaged memory, these last were desirable features. The centuries had shrunk to decades, then to years, and finally to days. Ilsa was within the orbit of Abel's gas giant. 10 million kilometers ahead, her target swept along a nearly circular path about its sun, Abel. 27 astronomical units beyond Abel gleamed Baker. But Ilsa kept her attention on that target, Abel 2. Now she could make out its gross continental outlines. She selected a landing site and performed a 200 meter per second burn. If she chose to land, she would come down in a greenish, beclouded area. 12 hours to contact. Ilsa checked each of her submines one last time. She deleted all malfunctioning circuits and reassembled herself as a single mind out of what remained. Over the centuries, 1/3 of all her electrical components had failed, so that besides her lost memories, she was not nearly as bright as she had been when launched. Nevertheless, with her subminds combined, she was much cleverer than she had been during the cruise. She needed this greater alertness, because in the hours and minutes preceding her encounter with Abel 2, she would do more analysis and make more decisions than ever before. 1 hour to contact. Ilsa was within the orbit of her target's outer moon. Ahead loomed the tentative destination, a blue and white crescent 2 degrees across. Her landing area was around the planet's horizon. No matter. The important task for these last moments was a biochemical survey. At least that's what her surviving programs told her. She scanned the crescent, looking for traces of green through the clouds. She found a large island in a Pacific-sized ocean and began the exquisitely complex analysis necessary to determine the orientation of amino acids. Every 5th second, she took 1 second to re-estimate the atmospheric densities. The problems seemed even more complicated than her training exercises back in Earth orbit. 5 minutes to contact. She was less than 40,000 kilometers out, and the planet's hazy limb filled her sky. In the next 10 seconds, she must decide whether or not to land on Able 2. Her 10,000-year mission was at stake here. For once Ilsa landed, she knew that she would never fly again. Without the immense booster that had pushed her out along this journey, she was nothing but a brain and an entry shield and a chunk of frozen water. If she decided to bypass Able 2, she must now use a large portion of her remaining propellants to accelerate at right angles to her trajectory. This would cause her to miss the upper edge of the planet's atmosphere, and she would go hurtling out of Able's planetary system. 13 months later, she would arrive in the vicinity of Baker, perhaps with enough left in her rocket to guide herself into Baker 2's atmosphere. But if that planet should be inhospitable, there would be no turning back. She would have to land there, or else coast on into interstellar darkness. Ilsa weighed the matter for 3 seconds and concluded that Able 2 satisfied every criterion she could recall, while Baker 2 seemed a bit too yellow, a bit too dry. Ilsa turned 90 degrees and jettisoned the small rocket that had given her so much trouble. At the same time, she ejected the telescope which had served her so well. She floated indivisible, a white biconvex disk, 12 meters in diameter, 15 tons in mass. She turned 90 degrees more to look directly back along her trajectory. There was not much to see now that she had lost her scope, but she recognized the point of light that was Earth's sun and wondered again what had been on all those programs that she had forgotten. 5 seconds. Ilsa closed her eye and waited. Contact began as a barely perceptible acceleration. In less than 2 seconds, that acceleration built to 250 gravities. This was beyond Ilsa's experience, but she was built to take it. Her body contained no moving parts and, except for her fusion reactor, no empty spaces. The really difficult thing was to keep her body from turning edgewise and burning up. Though she didn't know it, Ilsa was repeating, on a grand scale, the landing technique that men had used so long ago. But Ilsa had to dissipate more than 800 times the kinetic energy of any returning Apollo capsule. Her maneuver was correspondingly more dangerous, but since her designers could not equip her with a rocket powerful enough to decelerate her, it was the only option. Now, Ilsa used her wits and every dyne in her tiny electric thrusters to arc herself about Able 2 at the proper attitude and altitude. The acceleration rose steadily toward 500 gravities, or almost 5 kilometers per second in velocity lost every second. Beyond that, Ilsa knew that she would lose consciousness. Just centimeters away from her body, the air glowed at 50,000 degrees. The fireball that surrounded her lit the ocean 70 kilometers below as with daylight. 450 gravities. She felt a cryostat shatter and one branch of her brain short through. Still, Ilsa worked patiently and blindly to keep her body properly oriented. If she had calculated correctly, there were less than 5 seconds to go now. She came within 60 kilometers of the surface, then rose steadily back into space. But now her velocity was only 7 kilometers per second. The acceleration fell to a mere 15 gravities, then to 0. She coasted back through a long ellipse to plunge almost gently into the depths of Able 2's atmosphere. At 20,000 meters altitude, Ilsa opened her eye and scanned the world below. Her lens had been cracked and several of her Gestalt programs damaged, but she saw green and knew her navigation hadn't been too bad. It would have been a triumphant moment if only she could have remembered what she was supposed to do after she landed. At 10,000 meters, Ilse popped her paraglider from the hole behind her eye. The tough plastic blossomed out above her, and her fall became a shallow glide. Ilse saw that she was flying over a prairie spotted here and there by forest. It was near sunset, and the long shadows cast by trees and hills made it easy for her to gauge the topography. 2,000 meters. With a glide ratio of 1 to 4, she couldn't expect to fly more than another 8 kilometers. Ilse looked ahead, saw a tiny forest and a stream glinting through the trees. Then she saw a glade just inside the forest, and some vagrant memory told her this was an appropriate spot. She pulled in the paraglider's forward lines and slid more steeply downward. As she passed 3 or 4 meters over the trees surrounding the glade, Ilse pulled in the rear lines, stalled her glider, and fell into the deep, moist grass. Her dun and green paraglider collapsed over her charred body so that she might be mistaken for a large black boulder covered with vegetation. The voyage that had crossed 100 centuries and 4 light years was ended. Ilse sat in the gathering twilight and listened. Sound was an undreamed-of dimension to her. Tiny things burrowing in their holes, the stream gurgling nearby, a faint chirping in the distance. Twilight ended and a shallow fog rose in the dark glade. Ilse knew her voyaging was over. She would never move again. No matter. That had been planned, she was sure. She knew that much of her computing machinery, her mind, had been destroyed in the landing. She would not survive as a conscious being for more than another century or 2. No matter. What did matter was that she knew that her mission was not completed and that the most important part remained, else the immense gamble her makers had undertaken would finally come to nothing. That possibility was the only thing which could frighten Ilse. It was part of her design. She reviewed all the programmed memories that had survived the centuries and the planetary entry, but discovered nothing new. She investigated the rest of her body, testing her parts in a thorough, almost destructive way she never would have dared while still centuries from her destination. She discovered nothing new. Finally, she came to that load of ice she had carried so far. With one of her cryostats broken, she couldn't keep it at its proper temperature for more than a few years. She recalled the apparently useless leads that disappeared into that mass. There was only one thing left to try. Ilse turned down her cryostats and waited as the temperature within her climbed. The ice near her small fusion reactor warmed first. Somewhere in the frozen mass, a tiny piece of metal expanded just far enough to complete a circuit, and Ilse discovered that her makers had taken one last precaution to ensure her reliability. At the base of the icy hulk next to the reactor, they had placed an auxiliary memory unit, and now Ilse had access to it. Her designers had realized that no matter what dangers they imagined, there would be others, and so they had decided to leave this backup cold and inactive till the very end. And the new memory unit was quite different from her old ones, Ilse vaguely realized. It used optical rather than magnetic storage. Now Ilse knew what she must do. She warmed a cylindrical tank filled with frozen amniotic fluid to 37 degrees centigrade. From the store next to the cylinder, she injected a single microorganism into the tank. In a few minutes, she would begin to suffuse blood through the tank. It was early morning now, and the darkness was moist and cool. Ilse tried to probe her new memory further, but was balked. Apparently, the instructions were delivered according to some schedule to avoid unnecessary use of the memory. Ilse reviewed what she had learned and decided that she would know more In another 9 months,